Hello everyone, now we have to discuss the standard inputs in circuits. First, I would like to discuss step input, or you can say unit step input. Unit step input. This is the most common input that we are using in electrical engineering. The most common driving function or driving input. The most common driving input in electrical engineering, right? So it is defined as u of t, that is unit step, u of t, that is in time domain. U means what? Unit step, right? So 0 and 1. When it is 0, when t is less than or equals to 0, it is 0. When t is more than 0, the value should be equals to 1. That is, we can say that let us say this is t, this is u of t. For this, the value should be equals to 1. That's why it's said to be unit step function. That's why it's said to be unit step function, right? So this is the value t more than 0. This is t which is equals to 0, right? This is t less than 0. This is the reason, right? This is about the representation of unit step function. So we can write that point. The input has no magnitude for the time t less than or equals to 0 and has a positive unit magnitude at a time t greater than or equal to 0, right? So therefore this is the introduction of unit step function. Therefore the Laplace transform of this unit step function, the Laplace transformation can be obtained as, we all know that f of s, which is equals to what? Laplace transform of f of t, right? That is Laplace transform of u of t, that's it, which is equals to f of s, which is equals to integration 0 to infinite e power minus st into u of t dt. Simply u of t means what? 1, right? That is f of s, which is equals to 0 to infinite 1 into e power minus st dt. We all know that e power minus st dt is nothing but e power minus st by minus s, which is equals to e power minus st by minus s. The limits are what? 0 to infinite. So after substitution of this upper and lower limits, we are having f of s which is equals to 1 by s, right? This is the Laplace transformation of unit step function, that is 1, right? If it is 1, we are having 1 by s. If it is a, we are having a by s. For unity step input. Similarly, u of t which is equals to a. Therefore, what about Laplace transformation of a which is equal to what? A by s. That's it, right? This is about the concept of unit step input. Or we can write one important point, one important node point. Important node. So the unit step function or input in electrical circuits represents the closing of a switch applying at a constant voltage. The unit step input in circuits what represents the closing of a switch applying a constant voltage, that is V, okay, to the circuit. Obviously, Laplace transformation would be what? E by s. This is V, right? We are applying constant voltage V. Obviously, for that, what is the Laplace transformation of V? That is unit step, right? Obviously, it is V by s only. This is very, very important observation. That is simply this is the input voltage, right? Let us say this is V initial, this is what? V final, right? This is the unit step representation. Next we have to discuss unit ramp function, unit ramp function or unit ramp input. Yeah, this is first. Now we have to discuss second one. Unit ramp input. A ramp input can be given by, that is f of t. Let us say it is t, it is not 1, right? Or t into u of t is nothing but t into u of t only, or you can say simply t, right? So for this what is the Laplace transformation, which is equals to 0 to infinite t into dt. We all know that t into dt is nothing but what? T square by 2 integration 0 to infinite. For this f of s, which is equals to what? We are having minus t e power minus st by s, limits 0 to infinite plus 0 to infinite 1 by s e power minus st dt, which is equals to finally what we are having 1 by s square. That is the Laplace transformation of ramp input, which is equals to 1 by s square. That's it. For unit step we are having 1 by s. For ramp input we are having 1 by s square. That is the function is what? F of t, which is nothing but t only. Then the representation is what? Simply let us say this is t. This is r of t, which is equals to what? T into u of t. Okay, which is equals to r of t. R of t, which is equals to f of t. Ramp means, right? That's why we represent with small r of t. Therefore, which is nothing but what? Linear, right? See, t, simply it is nothing but r of t is nothing but what? T only. That's why linear. So this is about ramp input. Okay. Next we will discuss parabolic input. Third one, parabolic input. Let us say for this f of t should be or p of t or f of t. You can consider anything. F of t would be t square, right? Therefore, Laplace transformation of f of t, which is equals to f of s, which is equals to 0 to infinite t square into e power minus st dt, right? From this, what we are having? We are having simply f of s, which is equals to t square e power minus st by minus s 0 to infinite minus 0 to infinite 2t e power minus st by minus s into dt. So here we are having t square into e power minus st by minus s. Obviously between these two limits this should be definitely is equals to 0. So this one and this minus gets cancelled. Finally what we are having? F of s should be equals to 1 by s 0 to infinite, sorry, here we are having 2, right? T into e power minus st dt. We all know that this is what? This is what? Simply ramp, right? Ramp input. For that ramp input what we are having? Therefore f of s should be equals to 2 by s. For this 1 by s square. Finally f of s is nothing but 2 by s cube. This is for what? Parabolic input. For this what we are having? This is t, this is what? Which is equals to, can we write p of t, p of t. Then what is the graph now? Obviously we are going to parabolic, right? T is increasing but p of t is nothing but t square. Obviously we are going to get like this. This is parabolic input. Like this we have to represent for different input functions. So the most common function is nothing but step in input only, step input, right? So let us consider next one, impulse. These are the main standard inputs. Impulse input. What is impulse input? That is f of t should be equals to delta of t, that is Laplace f of s is nothing but what? Simply it is 1. Simply it is 1. This is very very important observation. You will have better concept in signals and systems, don't worry. Here I am providing the concept regarding the circuit analysis only. Okay, that is for this. This is what? Delta of t. This is t. That's it. This is 1. When t is equals to 0, this is what? When t is equals to 0 only. Other than t equals to some value, obviously we are having 0. This is about impulse input. Next, let us take some exponential function, right? That is f of t, for example, e power minus at. For this, f of s is what? 0 to infinite e power minus at into e power minus st dt, right? From this we are having e power minus a s plus a into t dt. There f of s is what? E power minus s plus a by minus s plus a. Limits are what? 0 to infinite. From this what we are having? 1 by s plus a. That is f of t is what? E power minus at. Like that f of t which is equals to e power at. For this f of s is what? 1 by s plus a. For this f of s is what? 1 by s minus a. These are the very important observations. So exponential function is completed. Next we will discuss derivative function. Derivative function. What is derivative function? D by dt of f of t, right? That is d by dt of f of t, which is nothing but what? F dash t, right? F dash t. Simply Laplace transformation of f dash t, which is nothing but what? We can write s into f of s minus f dash 0. What is this f dash 0, sir? This f dash 0 is there, no? That is initial value, right? That is initial value. Sorry, this is only f of 0, not f dash. Initial value. Right? Next, sorry, 7th one, that is integrating function. What is integrating function? Integration of f of t dt, right, which is equals to what? One by f of t, or you can say Laplace transformation of integration of this function should be equals to what? F of s by 1 by s. 1 by s means what? Integrating function, minus f of 0 by s. Here also this f of 0 by s represents what? Initial value. So these are the basic functions, but the standard inputs are what? Unit step input, ramp input, parabolic input, and impulse input. That's it. Okay, based on this you can get any of the input functions like this. See, for 1 by s, f of t is what? 1. For that we are having 1 by s, right, like this. So these are the simple representations of Laplace transformations of different functions. So e power at 1 by s minus a, like that. T into e power at, we are having what? 1 by s minus a whole square, like that. We are having different functions. Okay, so here I forgot to tell you one thing. See, note point, f of t, for example 1, f of t, f of t square, right, which is nothing but what? 1 in the sense, 1 in the sense t power 0, right? Here t power 1, here t square, right? For this, Laplace transformation is nothing but what? 1 by s. This is nothing but f of s. For this 1 by s square, for this 2 by s cube. So like that, for example, f of t, which is equals to t power n, then what is the Laplace transformation? Simply we are having n factorial by s power n plus 1. This is the generalized formula for this. Okay, example, f of t, for example, t power 6. Therefore f of s, which is equals to 6 factorial by s power 6 plus 1. That is, f of s is what? 6 factorial means what? 6 into 5 into 4 into 3 into 2 into 1 by s power 7, right? 720 by s power 7. Like that we have to write. This is the generalized formula. Okay, yeah, that's all for this.